Hi all. I think I've addressed this a little bit, but let me look at it a little bit more. Let's use rational exponents to simplify these three radicals. I've got the 10th root of y to the 5th. So we can rewrite that with a rational exponent as y to the 5/10, and that reduces to y to the 1/2. And since it started as a radical, I'm going to finish this as a radical and rewrite this y to the 1/2 as the square root of y. There is a little bit of a shortcut I guess we could have done here. We could have gone straight to the answer from the outset here. You take the index of 10 here and divide it by the power of 5, and that'll give you your new index of a 2 right there. So 10 divided by 5 is that 2. You could think about it that way if you wanted. This next one's going to be a little interesting. That's the I'll write this as the 4th root of 3 squared. This 4th root of 9 is the same thing as the 4th root of 3 squared. Now let's write that as a rational exponent. That's 3 to the 2/4. 2/4 reduces to 1/2. So that's going to be the square root of 3. So the 4th root of 9 really does reduce down to the square root of 3. Now let's look at the 9th root of a to the 6th n cubed. If I rewrite that as rational exponents, we'll be looking at a to the 6 ninths times n to the 3 ninths. That'll be a to the 6 over 9. That reduces. They're both divisible by 3, so that'll be 2/3. And this n to the 3 ninths, that'll reduce to 1/3. And then we can turn this back into a radical by, for lack of a better term, factoring out the 3 in the denominators, keeping in mind that since they're in the denominators, that 3 is going to be the cubed root. And everything else will be left inside. So a to the squared power, n to the first power, or just n. And there it is, the cubed root of a squared n. That's it.